Hi people. So my name is Janmejay. I work on the retail platform team at Flipkart. I specifically work on the team that deals with pricing. This talk is about a bunch of things I observed and some of which I fixed and some of which I learned how to fix from others. There are things that cause pain when you work as a team because you have to wait for something to finish, or somebody has screwed up and now the fixing requires some time and you're waiting and there's an urgent fix. So all of that can be avoided by following certain principles. The most basic principle is observe. In an activity, where are you spending most of your time while waiting for something, and try to fix that, right? So that is the general theme of the whole discussion, right? So there are times when you're waiting for, let us say, a relatively minor thing, right? You're intelligent garbage collecting. You have to wait for 2 seconds. Well, it doesn't matter as much, but if you are working with like 4 code bases open at the same time, and 2 of them were like over 10,000 files, now the GC will take more time. Now you'll probably wait for 10 seconds every time with GCs, right? So the more painful it starts becoming, the more attention you should be paying. And this session actually covers some of these things that I observed over time and either fixed or helped fix. So the general theme of the talk is around a few top-level bullet points. So automation being automation testing and automation of your build, and automation of deployment and everything. ENV platform tools is around knowledge of the deployment environment, knowing how well can you diagnose a problem and apply a fix from the point when the problem happens to the point when you apply the fix. What is the time, right? Customization and tweaking. So the initial 2 are heavily team-oriented. They are relatively less individual-oriented. Towards the end, we are getting towards individual-oriented things as well. So customization and tweaking is, it has a fair chunk of individual-oriented items inside it. The choice of hardware is more, again, which you can do at a team level. Your organization obviously has to back you, but being diligent and trying to find how it will help you and being able to substantiate it goes a long way in helping your organization make that shift. And routine and discipline is something that can be followed either at a team level or individual level. It's generally relatively harder to follow at a team level, but at least you can discipline yourself, right? So these are the top level themes. You start with automation. So why do you write tests? You would have heard maybe in your previous companies, this company, previous teams, this team, from your colleagues, of stories about people making themselves productive by not writing tests, trying to speed things up. I have a very tight deadline. I can't deliver if I do complete CI and testing and all that. So it is very similar to driving a car without brakes. You can go very fast, but when you have to stop, you have no control over it, right? Or it is like a gymnast who is trying to practice without a cushion on the ground. So if you have tests, it allows you to actually drive faster because your car has brakes now. You can stop when you need to, right? It'll act as a safety net. When you fall, it'll prevent the injuries. You won't deploy a bug to production, realize after 5 minutes the bug is there by watching logs, and then roll it back and then do some RCA and try to figure out why the bug is there and then fix it. So you don't have to go through those cycles just because you have tests. That is why you write tests in the first place, right? Does everyone know what CI means? Continuous integration? Heard of the term? So continuous integration is where you have written this suite of tests. Your strong safety net is there. But how do you ensure that all the tests are passing all the time? You make it a team level activity. So you don't worry about the developer forgetting to run the build before he checks in. You actually deploy a server which is responsible only for running builds, right? That is a CI server. Your CI server runs all the tests all the time on every check-in if possible, or at least on every push if possible. And you get to know when your tests fail. What it helps is easy maintenance and evolution. You can understand why, right? That is guarding existing features. If you break something, they'll tell you. CI will help help keep these tests fresh. So you won't have a test that you haven't run in the last 1 week and now you're not sure whether it broke on the 3rd day or the 5th day or the current day, right? So that kind of thing doesn't happen. Manual testing is only a last resort. There are things that you have to manually test where there's very heavy integration between systems involved. There are like 5 services and there's very heavy integration going on and there's no single front end where you can drive a functional test. That's when you resort to manual testing, but that should be the bare minimum. The time invested in writing tests and configuring CI and making CI work is very well worth it because it will save you a lot of time going forward. It will save you sleepless nights. So there's a concept of personal builds that I started following in my previous team. There was somebody named Chris Stevenson who introduced me to this. A personal build is like your CI server, but it is dedicated for you. You make your changes, you make like 2 or 3 commits, and when you're ready, you think that at least one subunit of the functionality you're trying to implement is finished, you can actually push it to the personal build server. You don't have to build it anymore. Your test suite might take like 25 minutes to run on your laptop, but you can just delegate it and you can continue working on your laptop, right? The problem with running the build locally is that if you've written enough integration or functional tests, they will be inserting and deleting and doing whatnot to your DB. They'll be doing something to the files. The log files will get modified. They might be monitoring on certain files that you're going to touch when you run tests from an IDE and your build is already running. So the build might start failing because you touched a file which is not supposed to be touched, right? Or you inserted a record which is not supposed to be inserted. The test has failed because you're running it from the IDE and from the build at the same time. So all of that does not need to happen and you don't need to wait for the build to finish. You just push it to the personal build. The personal build will finish it off at some point. You can go and watch or you can configure notifications. It will be delivered to you as an email, right? All CI servers have these basic features. So by PB I mean personal build is not a sacred cow. CI build should be treated as a sacred cow because if you break that, suppose one of my teammates is trying to commit something really important and I break the CI build, now he has to wait for me to fix it. If he checks in over a broken build, what he has now done is he has made it very hard for me to find out whether a test is failing because of his check-in or because of my check-in. When I am the first one who has broken the build, I immediately know that it is my check-in which has failed the build, right? If like 4 fellows have checked in after me, now none of us are sure that the 4th build which is red, is it because of me or is it because of someone else or is it a contribution of 2 or 3 commits, right? So all of that can be avoided by keeping CI green. When CI goes red, you look at it immediately and you fix it. For running personal build running the build without hurting your development cycle, you can use personal build. It only takes like 10 seconds to push to a personal build, hardly. So this is a CI/CD server. This server is called Go, but you can use anything else. Just fit it with the CI server that you have been using. So you can see that there are some pricing code bases here. Maybe the font is not visible, but it's pricing XYZ, pricing ABC. There are multiple builds that pricing has. And there is pricing personal builds where I have JJ, which is my alias, JJ pricing X, Kaustubh pricing Y, right? So this is at a user level. So when I push to my personal build server for this XYZ code base, this build is going to run and it's going to tell me whether my build is good or not, right? And I don't have to wait for those 25 minutes, I can continue hacking away, right? Even if you don't have a CI server, it's very easy to emulate. All you are doing is you're saying, Git, show me all revisions that are not available from head, which is what I'm currently on, and available from that ref. So that ref being your personal branch. So it could be master, it could be anything else, right? And pushing to personal build is as simple as the git push command that I've shown. This is my personal build. So if I just do git push force personal, which means I may be destroying commits, I may have clobbered commits together. It will still allow me to force push, and I'm saying my head should go to the remote master. And the CI will be watching using that command, substituting a ref with master, right? Very simple. Very easy to do, very effective. It can save you hours together. So in my previous team, my build used to be about 3 hours. It was a 4-year-old code base, very heavily loaded with features, very heavily loaded with integration tests, and very heavy DB interaction, and multiple threads interacting, multiple in-memory queues in the entire picture, right? So that used to take about 2.5 hours. And to speed it up, we did two things. One, we just parallelized it. We introduced a parallelization library. There are multiple out there. One that we were using was TLB, which was developed by us as well. And we made a personal build. So within 9 minutes, we would push to the personal build and know whether the build is passing or not. Instead of waiting for 2 hours and 7 minutes on my laptop, I would just wait for 9 minutes. And even in those 9 minutes, I would be hacking more code while CI is doing its work, right? So that's the effectiveness of personal build. ENV platform and tools. A lot of teams go to the extent of saying, every morning you come to the office, your workstation, so this is especially true for teams that have shared workstations, your workstation will be reset. There'll be a cron job that runs midnight. It wipes everything clean, installs what you need to have for the application, and when you come back in the morning, it's all fresh. So you'll never run into any issues with, some record was there in the DBA because of which your test was failing. I took 9.5 minutes to debug it, and then eventually I figured it out and I've deleted it, now it's fine. So all of that does not happen there, but heterogeneous WNV is good for a few reasons. It may catch issues early on. For instance, I may write some code which say has a bug, let us say in a Windows setup. And suppose I'm working on a project that is supposed to work across Windows and Linux and Mac and whatnot, and Solaris, right? In that case, if I've caught a bug early on, it's a great thing, right? So in those kind of cases, heterogeneous WNV actually helps you. It doesn't hurt you at all, right? It tells you about incompatibility, behavioral differences, non-availability of a library. You end up catching those issues very early on. This is phenomenal. This is more important than that. So team members can use the toolset and ENV they're comfortable with. I won't tell you, boss, you have to write your code in VI when you're writing Ruby code, right? You can write it in whatever you're comfortable with. You write it in maybe Notepad if you want. If you're really comfortable with it, if you're really, really, really fast with it, right? So team members get to use the toolset they are comfortable with. Use IntelliJ, use Eclipse, use whatever else that you find works best for you. So they are most productive with it. The other misnomer is usually when teams go into that model where your workstation will be prepared completely fresh for you, ready for you to start working, they have to decide upon a certain DevEnv toolset. So they would decide, let's say, IntelliJ with Ruby mode for Ruby, or IntelliJ with the Python plugin for Python. The fact is that Emacs and Vim outshine everything else when it comes to scripting languages, non-Java, essentially. Even C and C++, Emacs and Vim outshine everything else, hands down. So it's worth a try. Just an example, I put a screenshot here which is showing, so this is a mock thing, of course. I'm trying to debug an issue that does not exist. I'm just trying to show what's going on. You could have a process running here. You could have a debugger attached to that process. For people who have used GDB, they would recognize the shell, the top shell, right? This is a GDB console, right? Instead of just getting this console and firing L and P and H and BT and things like that, you have that shell. You can do whatever you want if you want to do it. And you have your source code, you have line level breakpoint, you have your stack trace, you have registers, you have local variables, you can have disassembly, which I have not shown here, right? So you'll have the ISA level instructions line by line inside a buffer. You have the std out, stdr console, and you have the threads that you're running in this process, right? Amazing, makes for a brilliant development environment. If you try to do the same thing for Ruby or Python using IDEA, my guess is you'll end up with something substandard. When I tried last, it did not have Ruby debugging support, which would work. So I have something that they say works, but it doesn't quite work when you try it out. So this is the power of editors which have won multiple versions of releases over the years versus something like IntelliJ, which works very well for Java but doesn't work very well for other things. So context switching for devs, context switching is for CPUs, right? We are not really good at it. So the most important thing, if easy, please avoid context switching. It wastes your time. You're trying to work on some feature, you have now thought through how the service API is supposed to be, you have thought through how you're going to integration test it, you've loaded a database, and your manager comes and tells you, boss, you know what, that fix has to go out first. Now you context switch, right? You cannot avoid it all the time. So get a tool like Git which helps you context switch very often, very fast. Use branches. Git supports really lightweight branches. It works really, really well. You just need a bit of getting used to it, so you need to give it like half an hour for you to adjust with it. Once you are adjusted, it works amazingly well. Branch development plus personal build makes for an awesome combination. So what I can do is I can be working on 3 features at the same time. Suppose the first feature has a bug. I've just deployed and realized it has a bug. I can write a test, I can fix it, and I can push it to personal build. I can go to the second branch, implement one more test, write code for it. By the time the test is passing, I can stash this change, I can go back to the other branch. I have realized that the personal build has failed. I make a commit, I push it to the upstream, and continue working with the other branch, right? So branching plus personal build makes for an awesome combination. You don't even have to stay on that branch. You just push it to personal and you move on. So you can actually go to the extent of creating multiple CI builds, each one for a branch, if you want to go to that level, right? Stash is really amazing. So you can have half-done changes that you don't quite want to commit. It doesn't make for a nice unit of work. So you don't commit it, you stash it. Give it a nice name, you can bring it back anytime you want. This takes like less than a second to do. Bisect is really amazing. I have used it only a few times in my entire life. Luckily, the places where I have worked, there was some sanity with respect to test and CI, and the people were really smart. But if you are in a situation where you're trying to find this bug that got introduced like 1 month ago and the deployment hasn't happened and now it's breaking, Bisect is an amazing feature. You can actually automate bisecting using a script. If you have an automated test, right, which catches this bug, which returns a non-zero exit code, you can actually write a shell script which will do git bisect good, git bisect bad based on whether the test is failing or not. And you can keep bisecting, and in login you can reach the commit that actually started the problem. So you can do it manually, still you will reach in login, but you have to fire the commands. If you automate it, we'll just do it for you. You can go home, come back tomorrow morning, it's done. Right? So git bisect is a very amazing feature. Go back and read about it. Learn. So some things that always help, even if you're working in managed environments, knowledge of GDB is something that goes a long way in helping you debug problems. So there are bugs introduced. So especially when you work in a product environment, right, where other people are users of your product, you have very weird bug reports where they say my JVM has crashed with this kind of an exception, and you have no idea. Allocation.cpp line number 22 is failing. That's it. That's all you know, right? And he'll tell you the version of JVM. Now you have to get that JVM, and you have to figure out what's going on allocation.cc line number 22. You can't ask him to upgrade because it is organizational policy to not have any other JVM version than 1.6.0_32, right? You land in situations like that. GDB will really help you in those cases. Or suppose you are in a situation where your database has gone into a deadlock. You know, if you exactly know what the problem is, you can actually recover. You don't have to kill -9. You can attach GDB, you can change a certain variable, it'll be spin looping over that, it'll just get through, done. It's as simple as that. So if you know the general area of issue, GDB will help you nail down the issue exactly. So it's really good at that. So by cousins, I mean, whatever, you know, like DDD and all that, data display debugger, GNU visual debugger and all that. Utilities like awk and sed and general comfort with shell scripting. So daily mundane tasks, I have to like partition the CSV into 4 parts and apply different values to each of the parts and then send a mail. I can write a script for this, or I can keep doing it manually in a spreadsheet, right? It's way easier to invest 10 minutes writing that script, getting it right. But in order to get it right in 10 minutes, you know really good knowledge of awk, really good knowledge of sed, really good knowledge of tr, cut, whatever else, and shell, right? So this is totally so worth investing in. Intricate details of a deployment ENV. This would, for a Java ENV, it'll mean GC ergonomics. Do you know completely have you been watching what is the survivor ratio that works well for a app? For how many generations are object kept in the survivor space? These are the kind of details that you need when at 12 o'clock in the night your machine has gone into a full GC mode and you want to fix it. You want to do something to fix it, right? These are the kind of details that will help you at that time. Knowing things like what is my object lifecycle? 90% of my objects die within first 10 seconds of creation. That is knowledge I can leverage at that time when I'm trying to debug a really, really crazy problem. and when somebody is waiting on me to fix it. Suppose I'm working on a really critical service and website is down because of the service. This will really help me at that time. Performance analysis monitoring tools. So right from your kit to Visual VM, JConsole, being able to use these tools effectively. Your kit has a lot of features around exception reporting as well. Everybody knows how to do CPU profiling. Everybody may know how to use memory profiling, but how many of us know how to use the deadlock detector or how to use the exception logging that your kit has? Nobody pays attention to these things, right? But it is a tab. It's worth paying attention to. So learn your performance analysis monitoring tools very, very intimately. Learn your GC log very intimately. It will tell you a lot of things, right? So these things are totally worth learning. All ID and editor shortcuts, dribbling with mouse here and there, trying to get a command working. Oh, why is it not working? All of that is symbol. All that are signs that you don't totally understand your ID. So invest in 100% understanding of it. And with shortcuts, you can drive things a lot faster. I mean, once you get comfortable with it, you will realize that you're going at a speed that was impossible without shortcuts. You just cannot drive that fast with mouse. And you prevent injuries because your hand doesn't have to go out of the keyboard. You stay on the home row, you keep typing, right? Anything else that you use day to day? Like if you're using spreadsheets day to day to perform some kind of analysis, write those macros, keep them handy, open the same spreadsheet, load the new data, and perform the analysis. Automate anything that you can automate in your everyday life. Right? So embrace ENV management is especially on legacy code bases, right? There are these conventions built. When you set up a legacy code base, you would be told, boss, you need to have this logging directory inside var log xyz, and you need to have this temp directory inside temp/foo, which is supposed to have this file, which is supposed to be empty when you start the app. So there are these conventions that are built over time and nobody bothers fixing them, but they hurt you a lot. When you're trying to debug an issue, you'll first realize, oh, I forgot to create that directory. Let me create that directory. Now let me try. Oh, the temp directory is not there. Then you go and do it, right? So all that is worth automating. And if you cannot automate it, if the code base is like 6 years old and there are just so many quirks that you cannot fix, use a virtual ENV. For instance, for GemMess, Ruby Gems Mess, you can use something called RVM, Ruby Version Manager. For Python and pip projects, you can use virtual ENV. There's slots and portage for Gentoo. If you need different versions of GCC, you can use slots to install different versions. And your OS can use one version which is stable, but your code can use 4.7, which is unstable, right? So you can do things like that. You can link executables to pick up dependencies from a specific path. For instance, I remember this Oracle binary MySQL driver, which just would not run on any computer that did not override LD library path to be certain thing, right? That is a very annoying thing. Maybe just compile that library with rpath and assume that the binary is installed in a certain location and nobody has to worry about LD library path anymore. You would have run into some developers that don't understand how LD library path works, right? It'll help them all. So use these tools to create your framework or your app or whatever. Use chroot. So in the specific case that I was talking about, where you had to create these 20 directories here and there and it'll dirty your entire installation, you can use something called chroot. At a process level, you can decide what should root be, and all the child processes will inherit it, all the threads will follow it, right? So you use that. You can segregate it into a sandbox and use the app from outside while it's running inside a chroot environment. It's a really amazing setup. And now you can start combining tools. So you can combine chroot and Git. So you can say that the chroot environment will be a part of my repository. And whoever wants to set up this project from scratch, he can just clone the repository, go to this branch has the right chroot environment, he can start the app there. That's it. It's that simple to start an app locally, right? And if even this can't fix, then the problem is really big. Then maybe you need to use VMs. But generally, you don't need to go there. I never had to go there. Make a send dev env. Generally, issues that only fail on your computer are to do with your computer. And you'll keep struggling with them and keep wasting 10 seconds every time they fail. Instead of that, spend 1 hour and fix that problem so that you don't have to keep spending those 10 seconds and every time be annoyed, oh damn it, it is failing again. That doesn't have to happen, right? Have scripts that take care of repetitive tasks. This ties into the shell script and awk and sed pointer that I had. Have aliases, have functions, have executables that let you do the daily thing, right? So I have, for instance, an executable called grepkill. I don't have to say pswalks grep this pipe awk print $2 which gets the PID and then say kill -9 or whatever kill, right? I have a command called grepkill. I say grepkill Emacs and it will kill Emacs. So have these nice utilities that you need from day to day is really worth investing in. Have smart shell, have it radiate information that you need all the time. For instance, have it radiate how many commits ahead of origin master are you in your repository. That means how many commits have you made which you haven't pushed, right? Or is it a dirty index? Have it radiate those kind of things. Or if you're working in a chroot environment, maybe make it radiate the directory which is the chroot environment in red. So that you know when you are inside chroot environment, when you're outside chroot environment, right? So you should not do sudo rm -rf varlib outside of chroot because then you're really bad, right? After that, there's no recovery. So, but at the same time, remember not to make it very resource intensive. Don't do lsla */*/java in a shell prompt, right? That will be really hungry. And use what you understand well. Generally, everyone says that Unix is a very dev-friendly environment, but I have seen people driving really, really fast with Windows. They would drive the file manager like we drive shells. They're that fast with Windows. So if you're really amazing with a particular environment, no matter what other people say, you should use it. It's not worth switching, right? The general notion of calling something user-friendly in general is not right. Like, user-friendly is a very subjective thing. It is always a function of how well you understand it. If you understand it 100%, it'll definitely be more user-friendly for you. For that guy that I'm talking about who drives file manager like that, of course, file manager is like more productive for him than a bash shell is, right? So remember that. So don't switch because other people are saying you should switch. Customization and tweaking is a more individual level thing. So maximize your screen space. Try to reduce the clutter that you see on screen. Dock bar may be required, but the top level menu bar may be not, right? So weigh things that you use versus you don't use and try to kill them. A tiling window manager is really good with all this. One, it does not have window decoration. The tiling window manager is something that organizes applications as tiles in your UI. So if you have this bigger screen, it would actually, let us say this is your screen, it will actually make tiles out of it. So the first half will be cut for one application, then the second half can be partitioned in two and be cut for two applications. And then the fourth quadrant can be cut in two again. So that's what tiling window manager is good at, right? So leverage things like this. And there are multiple tiling managers, there's not one. I use Xmonad, there are multiple others which work as well, right? So hide visible controls that you don't care about. IntelliJ especially is notorious for this. Comes with like 4 levels of buttons, of toolbar buttons. And most people don't use it. There's actually a button for undo and redo and show undo history and whatnot. It's amazing. It's like this much of buttons on top of your screen. If you get rid of that, I'll show you how IntelliJ looks after that. So don't fall for eye candy. Compass, Plasma, Clutter, Unity, these never help you with any work. So try to use what really helps you with work. Don't fall for jazzy UI and all that. So this is what a typical tiling window manager interface looks like. So this is a tiling window manager running. It's running 3 applications. For people who can't identify with this is IntelliJ, this is a Java IDE. That is Emacs. We have already seen it in the GDB while I screenshot. And that is a shell, right? So you can see a very thin top bar there, which is radiating some information about battery and how much CPU I'm using and how much memory I'm using, how much am I swapping and all that, what applications am I running in the dock, right? And this is telling me about my workspaces, but it is a very thin fringe. It is probably thinner than the window decoration that you have, right? And then none of my windows have any window decoration. In IntelliJ, you can see that there are no sidebars. There are no toolbars. There's only one menu bar which I've kept because not all things in IntelliJ are accessible via shortcuts. So that is what I've kept the menu bar for. Otherwise, that would have been killed as well. In Emacs, everything is of course accessible through shortcuts or through a typed command. So I have killed the menu bar, I've killed the toolbar, I've killed everything else, which doesn't need to be there, right? So in Emacs, you can actually see that it is just a window that has a bunch of text and line numbers. That's it. The shell is, it is running a terminal multiplexer. We'll come to that. So terminal multiplexer is something that helps you have one terminal but still multiplex into multiple sessions. So you could have a tab for SHing into production servers, a tab for SHing into staging servers, and a tab for running locally the tasks that you run and all that, right? It's really helpful for that. And it does not, you can see that it does not have any tabs. In this case, I have only one tab open, but even if I had multiple tabs, it wouldn't show up like the windowing tabs on top or on bottom. It will actually be virtual tabs in the multiplexer, right? So multiplex allows you tabination. So this is a tab that you see right here. So master the keyboard. It's totally worth it. Your hands are not supposed to move like this. I have injured my wrists doing the wrong things, which is why I always preach this one. So your wrist is not supposed to move like this. It's supposed to move like this, right? But this is of no use when you're typing. You actually move like this when you're typing. So you should not do that. It's a good idea to learn touch typing. You go a whole lot faster, plus you don't have to move your wrist much, right? Configure frequently used shortcuts close to the home row. For instance, a good example that I always use is the tmux escape shortcut. By default is Control B. It need not be. Control B is away from the home row. I have configured to Control J. J is under my index finger, right? J is one of those keys that has a little plastic peg. That means that it is supposed to be under index finger when you're touch typing. So it's really convenient. Control J is probably the most convenient shortcut on the entire keyboard. This hand for control, this hand for J, right? Caps lock for control swap is another one of these things. If you don't know that early on, you'll end up hurting your little finger. Use terminal multiplexer. It utilizes screen space really well, and it allows for swift navigation between tabs, between parts of the window that you open. You can cut the window into multiple parts, and you can see logs tailing from 4 different servers at the same time. So a terminal multiplexer is really good at those things. These are some of the examples of extreme customizations that I have done. This doesn't save you a lot of time, but this is just a contrast. This is to show how far you can go with customizations. You need not go this far. If you go this far, your value on customizing keeps diminishing, right? So for instance, personal build will probably save you hours together, right? If you're on a legacy project, if it has a lot of tests, your personal build will probably save you 1.5 hours every time you push to personal. But this won't save you hours. This will probably save you minutes and seconds, right? So for instance, CPU frequency tuning, I flip between max and min, and I never auto flip. So I have either performance governor or power save governor, and when I'm on battery, I go power save, otherwise I go performance. So that is one of the things that I do, and that works really well for me. IntelliJ is a Java app, but how many of us have thought about GC tuning it? If you have 3 code bases open, and if you're working on a small code base, your GC churn will be proportional to the code base that you're working on, right? So the other 2 will not have the same GC churn. You'll just be looking at code once in a while, but you'll not be actively working on them. You'll only compiling and running and all that, right? So you can, if you're in this kind of setup all the time, so I'm generally in a setup where I have one small and one big app. And the big app is what I'm not working on, small one is what I'm actually working on. So actually took a few minutes, watched, so I had enabled IntelliJ log long ago. That was about 1.5 years ago. So it was always logging. So I just spent some time watching it, and then I tuned towards it. Within 2 shots, I think I spent like 10 minutes overall. I had a setup where it went pauseless, right? So only managing is what I mean by pauseless, right? So page cache and swappiness tuning, define your thresholds correctly. If you're like 40% memory is going to page cache and then you're swapping your IntelliJ, then you're hurting your dev lifecycle, right? You can't run tests because IntelliJ will freeze, then it will come back, then you'll run the test, then it'll again freeze. So all of that does not need to happen, right? Just tune your page cache well and let it not swap aggressively. Tune your swappiness also, reduce the swappiness. It's by default 60, you can reduce it to like 2, 3, 5. I keep it at 5 generally. CPU and IO scheduler. If you're using SSD, why do you want to use anticipatory IO scheduler? Use no-op IO scheduler, right? So very simple things like that. CPU, CFQs by default, I think it works best. No wait time. When you're mounting file system, why do you need to capture the read time, the last time it was read? You don't, right? Disable it. So a choice of hardware is around, you cannot always make choice of hardware yourself. So it's more around a team level or rather an organization level thing. But being able to observe and make the right suggestions is important. So there was a session by Yogi. That guy was responsible for figuring out a solid state versus magnetic disk performance implications on the build. And he managed to reduce, I think, some 20 or 30 minute build to 8 minutes by using SSDs. And he then also did some benchmarks for DB performance over SSD, right? So these things can save you a lot of time. Why invest in, and SSDs are not that expensive these days. So think about it. Multi-monitor setup is something that we were using in a previous project with my previous employer. So what this allows you to do is you can run your whatever editor ID in one window, have the logs tailing in the other window, have another window for running commands once in a while, and you can watch it all at the same time. It is generally very productive, and especially in the setup that I was talking about, if you're not using a tiling window manager, and if you are supposed to be looking at one code base while writing code in the other code base, this setup really helps. You can keep one IntelliJ there, one IntelliJ here, and you keep watching one while you write in the other. Watch out for physical injuries, of course. I realized that docking station was hurting my hands really bad. Monitor alignment can hurt it really bad. If your monitors are too far apart, you'll be moving your neck all the time. That's not good. Even the height of the monitor and all that matters. So the last one is routine and discipline. So I have been partly following these things, and the hardest one by far is, so core working hours is when you are only supposed to work on what's most important, like your actual deliverable, right? So have no meetings time, but that's very hard to implement. But at least you can close your clients, your IM client, your Twitter client, your Facebook client. You can close your mail client. It is difficult to do as a team because once in a while somebody will come ask you questions about something, and it may be related to something urgent and you have to pay attention. But you can at least start observing it partly as an individual. And with my previous team, we used to have this implemented at a team level. So we would have 4 core work hours. We would not take any interviews. We would not meet anyone. But that was possible there because it was an isolated team. It was a product team. So it was not in a setup where things were failing and services were interacting and all that. So in our setup, it is relatively hard to implement. But there it was very easy, so we did it. It can be task driven. So you can decide that I will finish this off before I do X, right? So before I go to a meeting, I want to finish this off. That generally channelizes your energy much more and you go a lot faster. So yeah, this is one of the discipline things, and keep exploring. So you may find a lot better hacks that work a lot better in your scenario. So think about it. Yeah. That's it. Thanks for coming. Any questions? Do I use tabs or spaces?
Because each time we type a tab, it will be little finger which will be hitting it always. Huh?
Yeah. So happy marriage between tabs and spaces is you can configure your editor to print out 4 spaces every time you hit a tab. So you won't actually be.
It's always like yeah. But okay. No, it happens when I use a shell. For example, autocomplete. If I type GCC G tab GCC, yeah, I end up hitting a lot of with little finger tab. Is there any
Well,
solution to it?
I've never faced that problem, so I don't have first-hand solution to it. What I generally do for searching commands or auto-completion is whenever in doubt, I start typing. And I can generally type fairly quickly. So if it's 1 or 2 characters, I really type out those 2 characters and then disambiguate. It just disambiguates itself. So yeah. The ergonomic keyboards. I've never used an ergonomic keyboard either. I'm a big fan of the laptop keyboard actually, but different things work for different people. So yeah, that's just what works for me. So yeah, ergonomic keyboards, I've heard a lot of good things about them. I've never used one myself. Yeah, in most situations, you can actually do without a mouse. But in some situations, you have to use a mouse. If you're trying to do something over a VNC session, how do you do anything without a mouse there? You have to use a mouse, right?
If you're selecting text in a text editor like VI or Emacs, if you copy that one, it won't be copied to clipboard.
No, that is a very simple control. You can configure it. Uh, I don't remember where I have it, but maybe I can show it to you. Just 1 second.
Even if you select in visual mode, it won't be copied to clipboard.
Yeah, sure, sure. So I can't find it, but there's a configuration you can do to say that whenever you copy something, it should go to your OS clipboard, your X11 clipboard. So it's a one-line configuration in Emacs. I'm sure it's a one-line configuration in VI as well. It should be fairly easy to get. Yeah, I mean, you can Google it. You will definitely find it. That's how I found it. So an interesting tip with terminal multiplexers is let us say uh, if you are on a shell and if you have a lot of content printed, right? Now let us say you want to go and select something. Let's say these are different, right? Let's say it was a log file. You can actually whatever you see I'm doing from the keyboard. So you can select anything. You can paste it anywhere. So this is one of the advantages of using a terminal multiplexer. You can go really fast in copy mode, and you can go like page by page. So I didn't show you that, but I have only 2 pages. Well, but if you're telling a long file, you could go like page by page, and you can define the buffer size to be something, and you can page that much, find the right text, copy it. Yeah, works very well. In this case, I have 2 tabs open for people who can see this height. There are actually 2 tabs open. So yeah, that is tabination. I can switch between them from the keyboard. I never have to hit the mouse. Cool. Thanks for coming.